Alright, we're back. We are COMP305 in the fall 2019 semester at Centennial, week 2, part 2 of our broadcast. We're going to add more objects to our little game, right? Alright, back to Unity. So we're going to go hit 2B. So again, there's a bit of a glitch that we have, which we're going to figure out at some other point. Again, one thing to note is if we've created a WebGL build for this, and what ends up happening, here's the glitch. So when it runs right now, you have that little line that comes up, and we can see it here when we reset. And let's see what happens, see what the actual positions are. So this position is like 6.09997. Let's take a look at that, 6.09997. I mean, even though I'm adding 0.1 every time, I'm getting this really weird glitch, which is interesting. Well, it's not that. It's this. Look. So if I said 6.1, let's just, I'm curious, but let's put this at 6.1. So this is where it should be. So there's still, that doesn't solve the problem, right? So it's like we're off, by a bit. And let's look at this one too. So here's the other one. This is negative 8.39996, which is close. So let's say negative 8.4. So again, we're off the difference by quite a margin. It's not a small amount, okay? This is negative 8.4, and this is 6.1, right? So that's, a big difference. It's a huge difference in terms of what it looks like, right? So something's going on here. Now, I'm just going to uncheck this to see what happens if it corrects itself. But I don't think it's going to. Right? So you can see it runs pretty good, but then it comes to this part, and here it is again. And it's almost as if, some value is what's made it happen. And if I just kind of go to 1, alright, so here's the thing that happens. I'm doing it only for one ocean. Let's do it for the other oceans. So there we go. It's 1 for both. 1 for this one and 1 for this one. Now you can see that it's much worse. Take a look at that. See that? Sure. Well, you can see that problem. The problem is like huge amounts of space, right? Look. No, it's not okay. Then you're going to have big gaps, huge gaps. Look at that. Something doesn't look right here, right? So here's what the game view looks like. See, big gaps, big gaps. So let's go back and change this just for curiosity. Change this to something big, like 1.0. All right, and then run this again and just see what happens. Now you can see a much bigger gap than before. A much bigger gap. It's huge, in fact. Right? Look.
So that's like one is just getting further ahead.
It's almost like multiplication instead of addition. Like it's a huge gap. And if you look at our script, it wouldn't even say that that's something that's going to happen. Again, so our move script basically says, look, we got this new position. We got a new vector2 object with x and y coordinates with the vertical speed, which is 0.1 by default, and whatever we put into it otherwise, the vertical speed is going to move down, right? We set our current position to the position of the transform of the object, right? So that's what this does. And it says the world space position of the transform, which is perfectly fine to me. And then what this does, it's a vector2 object that uses the operator minus overload, right, to update its position with a new position. So here's new position, it updates, and then this transform position, we get it back, and we assign the current position to that transform. So the curiosity for me is where is the error happening. So if you're going to find this, you can do a little bit of output if you want. First of all, what is the new position? So we can sit there and say, I want the new position and the current position. And we can print those out. Print or debug.log. So if I go debug.log, that's the old way of saying print. We can put out a message. We can say that the new position is equal to some value. Some value, new position. And we could also say that current position right is equal to some value. So that's for this object here, right? This is when it resets. This is when it moves. Every frame, it's going to set this up. And let's just make a debug.log that shows a line, just so that way we have some separation. Okay? Alright, cool. Let's take a look at the stuff. Now, if we're updating by 1 or by 0.5 or whatever, we should get an actual number. Because what this is doing, vertical speed, is it's taking the original position. That new position should always be 0.1. 0 and 0.1. 0 and 0.1. That's what it should show every single time. Correct? And look at new position. New position is actually a vector. And I could do toString just to make sure that it converts the vector to string, but it does it automatically. There we go. There's a toString function. So I'm going to kind of push out the vector toString and see what happens. Let's try this out. And then we'll just stop it for a second. Oh, okay. And let's take a look at some of the options. So here's some of the output. -12.4. -13.4. This is current position. Look at that. It's exactly where it should be. Exactly where it should be. So these ones are all good. Right? Current position, current position, current position. And it does those very, very quickly. Alright? But what about new position? New position goes here once. Here's new position. Right? We hit this 116 times. Here's where the 116 times is. And the way this works is this doesn't change. 0.1 every single time. Right? It's like -19.2 down there, and then it flips. It keeps on going, doing this over and over again. So that's why these two are the same, because that's why it's showing this kind of situation, right? Does that make sense? So nothing's changed there. So it goes like, hey, my current position is -19.2, reset. So here's what could be happening that's causing this whole thing to happen. What if, and I'm just putting it out there to you, right? The rate of change of the object, it actually, there's a bit of a delay. So this is what's happening. Let's take a look at this, guys. Watch. What if? I think I'm figuring this out now. It is actually the code here. So depending on the speed, the larger speed makes it worse, right? So if we figure that as we move down the board, we're moving down the screen, right? And what if I go below 19.2 sometimes? Because look at my check bounce. The position of the y-axis, if we check it, if it's less than or equal to, reset point, right? Well, the reason why it could be lower than reset point is because I'm taking the actual physical position and then I'm moving it down X number of pixels per frame. Some frames, sometimes, right? Depending on the speed that I'm making go down, it's going to move further down, right? And if this is the position that I'm checking and I'm here and now I'm further down, sometimes what will happen is my check will be here where my bottom of my screen is actually below the 19.2 area, right? A lot. So I haven't reset here. I'm resetting down here. Well, I could, but that's not the issue. The issue is here's this one and here's this one. This one is moving so fast that I reset down here. I don't reset I don't reset when it gets there. I reset past it. So now I reset up here, right? But this one hasn't reset yet. And so now there's a gap. I'm moving so fast that there's a gap between this one and this one. That's the issue, right? And the slower I go, the less gap there will be because of my frame rate. It's my frame rate and how many pixels per frame that I'm moving down. And here's the other thing, guys. Remember, we have a ratio. We have a ratio of pixels that we're moving down the screen at the same time. So it's not exactly pixel perfect. Remember? Not exactly pixel perfect. So what if we were to explore that? And in other videos I've done this before, so let's do it together. So here's your ocean number 1. And if I go back to my project, and guys, see what you think here. So here's my texture. Here's my ocean texture. My ocean texture is 100 to 1, right? So what if I made this 1 to 1? So go back to 1 to 1. So I'm going to go, and I only have the ocean to deal with, so I'll do this right now. Apply. What this will do is it'll make the ocean massive, like this. Like it's massive. It's actually like 19, as an example, 480 units across, like meters, by 1440 meters above. That's why the whole ratio thing happened in the first place. That's why this happened, right? And again, it says maximum size and all that stuff is there, as well as the resize algorithm and blah blah. And that's why it's used the way it is. So what does my main camera have to be now? What does my main camera have to be? If this object, my ocean, is one thing, what about my main camera? It's 2.4. Well, the vertical size then would be 480. Right? Or something like that. Or 240. There it is. So there's the 240 mark. So now everything's the same as before. 240. Okay? The numbers are all wacky now because I'm getting to do different things. So instead of it vertical speed of 1, this will be actual pixels now. So let's say vertical speed will now be 5. So vertical speed is 5. The reset position and everything else has to be fixed because this is totally wrong now. So if I take the first ocean and I move it down, right? I want to put the first ocean somewhere else. So this is the top ocean, right? Remember? And again, you can see that this should be 480 pixels or something like that. There's 480 pixels. And here's the bottom ocean, and this should kind of work out to be negative 960. Okay, there it is, negative 960. And what's going to happen is as this goes down, right, it's going to keep moving down, negative 960. It's going to come to this point right here, negative 480. And this point right here, this is all in pixels now, right, we're dealing with. This point right here is going to be negative 1920. So bigger numbers, right? But it makes sense. Look, 960 is my restart position, and negative 1920 would be my other position because we're multiplying now by 100. Negative 1920, 960, right? With the speed of 5. Okay, so 5, 960, and 1920. 5, 960, and 1920. Okay, nothing's changed. We haven't overridden everything. We're just changing the scale. All right, let's see how this thing runs now. We've gone to pixel perfect. That means there is no ratio. Is this still going to cause a problem in terms of our updates? I'm trying to figure out the problem with you guys, right? Let's try it now. How does it look, first of all? Okay. It actually looks smoother in terms of the way it's going. The reset was weird. Let's see what happened there. Oh. Well, that's a problem. Yeah, negative 1920, Tom. Negative. That was good though. I mean, I think it's much smoother than it was, right? I mean, it just didn't do what I was expecting to do, but okay. Let's try it again. All right, look at that. There's still a bit of a gap. And it started immediately. It wasn't even like there wasn't a reset yet. Look. There it is. There's that gap that we want to try and find. So it kind of resets. And there it is again. It kind of goes right through, right there. And it kind of flows from one thing to the next. As soon as it comes down, there it is. And it's only on one side. Okay, so it's not a pixel perfect thing, but I can tell you this, that the way it looks, take a look at the difference in terms of how it looks, right? Here's pixel perfect, right? So to me, it looks better, right, than the other way. That's just the way it is. This is pixel per pixel. So when we say, 640 by 480, it's 640 by 480, right? So that's good. The weird thing happening with the separation, though, that's not a pixel perfect versus aspect ratio thing. That's something else. And I'm telling you, it has to do with how fast it's moving down the screen. Let's reduce that speed. Let's reduce both speeds down to 1. That'd be very slow, but we'll be able to see the issue even more. All right, so there's the speed. Both of them are moving right now at 1. That means 1 pixel per frame. Now it's going to take a long time for it to go down, but that's like 60 pixels per second right now. But my point is, you're going to see probably very little separation. But the reason why there's very little separation is because it's going to hit 1960, 1920, and then once it hits 1920, it's going to reset, right? But not before, and not after, right? Because it's only updating 1 pixel per frame. So that's okay. The reason why it was working before for itself, and we didn't see a problem, is there was only 1 of them, right? There it is. Still, look at that. So how's that possible? There must be something wrong with the calculations. And when we looked at the console was telling us that, hey, you know what? Everything is good. Look, there's my negative 480, right? There's my nice and even numbers, right? These are all the things that are good, right? But then we get into these funky numbers. Take a look at this. We should never have a 1087. Like, when did we get this? Look at this, 1088, 1089, 1091, and it's kind of moving up a little bit more at a time. Take a look at that. We should never have these numbers, ever, 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 because, it's negative 1920, but we're getting a bunch of these. So here's something we can try instead. Again, more debugging, and then I'm going to move on. I'm sorry, but it's one of those things, and I'm sure, Joshua, maybe you can appreciate how crazy it is when you have a bug and you don't know what the hell, why it's happening, right?
Well, I've had that countless times.
Yeah, it's going to come back.
It's amazing I still have all my hair.
Yeah, that's how it goes, buddy. So here's something we can try and do. So we got some printout happening down here. We have the debug.log, right? And what we're going to do instead is I'm going to output every time we reset, not when we move, but when we reset. I want to get the reset position, whatever that reset position is. I want to know what this new position is going to be, right, kind of stuff. What the current position is before we reset. So what I want to do is I want to output. I want to do debug.log, and I'll output the location of the reset position of when the thing happens, when it resets, how far it went down, as an example. So again, we want to get the transform dot position, and we want to kind of convert it to string, so to string. And what I want to also do is say reset. I want to print that out, see what happens. And hopefully that'll give us a clue of how far it went before it reset. And let's go back to this. And what I also want to do is I want to increase the speed back to what it was, to 5, which should give us maybe some clues as to what's happening. Alright, so reset was at 1925. 1920. 1920. But the first one was 1925. So it's interesting. So when the first one came down, right, we had that separation, and then it stayed there forever. Look at the 1920s happening. 1920 is exactly when it reset. That is the position. But we have 1925 for the first one, for some reason or another. Take a look at that. Did you see that? It went to 1925 before it reset the first time. And that's what causes separation. There's your separation right there, my friends. Because it only happened once. And once it was set up like that, it never happened again. So the question is, why? Now we know what happened, but why did it happen? Why did this occur? Let's see. Here's the other thing. Which one was the one that moved first? That crossed? And I believe it's ocean number 1. But let's check. And we're going to rename these ones. I'm going to say this is the top ocean, just so we're very, very clear. Or we'll call this, top ocean. And we'll call this the bottom ocean. So if the bottom ocean is the one that's closest to the bottom, is the thing that happens first. I believe it's the bottom ocean that crosses the line first. That's what I believe. And it could be because of the way I've set up these things in the first place. Remember that by default, what I've got them on is this one here is at negative 1920. That's where this one is already. Right? And this one is at negative 480. And now we know the problem. I don't have to even figure it out anymore. Do you guys see the problem? Look. This one is already at 1920. This one. This one here is at negative 480. This one is at negative 1920. It's going to move 5 pixels down before it triggers the reset. That's what's happening. So because of the locations of this thing, the way it works, it's already having a problem. So we'll change the position of everything. We'll say that what if, because remember this is supposed to reset back to 960. That's the reset position. So let's just reset it to 960. This one is going to go to 960. Right? So 960 should be here. 960. And this one, instead of starting where it started, we'll start it higher. We'll start on screen. Like this. There we go. And that, my friends, should stop the problem. Let's see if I'm right. Hey. And now you notice it resets every single time at 1920, and it doesn't matter how fast I move it. Even if I move both vertical, top ocean and bottom ocean really, really fast, if I go to 50, it won't matter. Oh, wait, maybe it does. Yeah, when you move too fast, obviously it compensates. But I mean, it's still, the separation is not that big at 50, but no one's going to move this fast. Let's try it again, and this time I'll move it at a reasonable rate of 10, because we're going to have other objects to move faster. How does that do for us? Is that going to change anything? Is that going to separate us? And the answer is, even at 10, it's pretty good. No hardware issue. It's a coding issue. It's a positioning issue. Here's 20. So when we go to 20, let's move this to 20 now. 20. Seems to be good even at 20. So I think we're okay. Alright, so now that we fixed our problem, we fixed our bug, we know what it is, we've gone back to pixel perfect. We need to go back to what it was, because pixel perfect is not the problem. I was moving back and forth to try and determine what the issue was. And I figured out now that it's not pixel perfect. And the reason why do I want to go back? Because, again, pixel perfect requires a lot more coding on the other side. Once I start going pixel perfect, then a lot of other stuff happens as well. So I'm going to kind of get out of here. So the code was okay. It wasn't the code, it was the stuff in the hierarchy that caused me to have the problem. And now I've got to go back to the ocean and the camera and move back to the way it was before. So I only changed one thing, so apply. And I'm also going to change the camera back to 2.4. And of course these positions are incorrect now, negative 480. It should be like negative 4.8. Negative 4.8. And this position here should be 9.6, which fixes it back to the way it was before. Both these change to 9.6, and this goes to negative 19.2. And the vertical speed can't be 5, that's insane, but it can be 0.05, which is what we want. Now we should be able to run everything without incident, and it'll look the same. So you see what I did there? All I did was move.
You guys see some of your hair falling.
Well, it is what it is, right? You know what they say.
Somebody trimmed a bit more correctly, you know?
Without incident, he said. Yeah. Yeah. No, that's the problem. The problem was that when we run this one, so this is the top one at 9.6, and this is negative 4.8, right? You see that there's no separation here between one thing and the other. There it is, right? So again, if I use the vertical snap to go up there, again, it's perfect. But the problem is that the reset position 9.6 up here, but this is negative 19.2, right? This one starting off at negative 4.8 is okay, because we're going to move down 0.05 units per frame, right? And the thing is, there's going to come a time where it's going to go below that area a little bit, and that's what's causing the problem. All right. And once it goes below negative 19.2, the problem with going below is there's going to be a separation between when it resets compared to the other one, because depending on how fast they are, right? But anyways, we got overall, I may have reset the numbers wrong, but that's the problem. The problem was that the positioning originally for where we put these things in the first place were wrong.
Did it not do this morning?
It did. It did, but I ignored it this morning.
I see.
Incorrectly, I might add, right? Anyways, let's move on. One more thing before we go. So I want to do one more thing. I want to add one more object. We have about 5 minutes left. So I want to add the island. Now the island should track, if you think about it, if you've got the ocean, the island can't be faster than the ocean, right? The island should go as fast as the ocean, because, I mean, the island's not going to fly or anything. That doesn't make any sense, right? Here's the thing: I only need one island, and I don't need to do one of these anymore. I don't have to claw back multiple islands here. One island is all I need at a time. So if I do this, and if I drag and drop my island into play, here's my island. Here it is. And what I want to do is I can create a prefab in a second. But again, we want to get this idea of an island controller. All right. So my island sprite is just like the other one, except, first of all, where is it? Now we want to try and start the island kind of off screen like this, right? At 2.63, let's say. So the island is going to start off screen, and then it looks like 2.69. Let's just really zoom in there just to get an exact number, and looks like something like this, 2.7, maybe 2.7 might be right. Alright, so 2.7 is where it's going to reset. That's the reset point of the island. Same idea, right? And then, so 2.7, and then it's going to go off screen over here. Here's where it's going to go off screen. And it looks like it's symmetrical again. It's going to come off around 2.7 again, negative 2.7. Let's take a look. Negative controller. And when we do that, we see that we have the same setup as before. Okay, now we know what we need. We need a move function, so let's do that first. The move function is going to work very similar to what we did with the ocean. In fact, it's going to be pretty much identical. Let's just, for the sake of things, copy everything. Everything. Just not the class itself. So all of this. Okay, so let's just replace the island stuff with all of this stuff. Come on, Visual Studio. And there we have it. We've replaced everything. We've got vertical speed of the same amount, except we know that 0.05 might be more reasonable. A reset position of 4.8 and a negative 4.8, which is wrong. It should be 2.71 and negative 2.71. We know that those are the numbers. Okay, there's the island. We have our start, we have our check bounds, just like before. We're gonna increase by vertical speed. When we get to a certain point, which is negative 2.71, we're going to reset. Okay, let's see how fast that is and if it works. And we'll just run it. It's a copy-paste operation at this point. But we're going to add a couple of other things. There's the island. Yay! And it's going to keep scrolling forever. Right? It almost looks good, except for that little gap. Right? That bugs me. Right? There it is. There's the island. It keeps on scrolling down, except for that little gap. And it's going to keep on going, and it's going to look like it's part of the ocean for the most part. Okay, but, that island can't stay in the same position the whole time. We want to randomize the position on the top. So whenever it resets this time, we want to move it across from this position. Let's click on the island. So as far left as this position, and again, if I just zoom in here, you can see that the leftmost area is about negative 2.883, let's say, that's what it says, all the way to 2.88. Negative 2.88, you see a pattern? 2.88, and that's the range. We're going to do a random range between negative 2.88 and 2.88. So that means when it resets, right? Here's our reset. Here we have a reset position, and it's going to be the speed. This is our reset position that's going to not going to be different. But this, right? This is going to be the actual x position, and this can't be the x position anymore. We have to calculate the x position of whatever this is going to be. So a random position. Okay, so let's say random x. We're going to say a floating point, which is random x position, right? Is equal to, again, random range between two numbers, a floating point number on the minimum and a floating point number on the maximum. So we know it's like the minimum will be negative 2.88 and a maximum of 2.88. That's what we said. That's what we saw as the minimum and the maximum. And we'll put the f's in there so because it takes a floating point number. Cool. So we've got our random x position, and we'll take this random x position and we'll pop it in here instead of maybe making it a 0. Nope. I meant just this. There we go. So that should give us a little bit of variation from one side to the other. Let's try that out. And of course we can't run it there, Tom. But we can run it here. Alright, so start it off over here. Wait, it's not... Oh wait, okay, good. So now you see it's coming down in different places, and it's going to give you a random range between one side and the other. So it looks like it's a different island, maybe. It's the same island, right? Hell, it's even oriented the exact same way, right? So there's not like a lot of challenge. Now, the right thing to do for us would be to have different islands, randomly spawning at different places, so you can have more than one island that you can interact with. But for now, you can see that this is just a random location on the top. Island done for now. Okay? Any questions around that? So all I did, I really just copy pasted this one. And the only thing I did different was this, where we did a random x position from negative 2.8. We measured it first. We went on the editor and measured it where it was supposed to be. and we created a random position from one side to the other. That's what happened here, right? All right, this is a great thing to stop. We're going to stop now, and I've added two objects, the ocean and the island. Next week we'll do the rest, right? And we'll add collisions. We'll add a scoring system. We'll add sounds. We'll finish the game next week, because that's how fast we got to be for next week. Okay. Oh, one thing to note before we go, and I'll record this as well. Remember that next week you're doing a 10-minute presentation with your team, max. I don't even know if it'll take that long. Okay. There's only 4 teams on both the first section and the second section. So have someone rehearse it. Don't just come in raw, right? And again, I don't want walls of text in your presentation. Try and make it fun, right? Be enthusiastic about the stuff you're presenting, okay? So what I'm asking you to do is don't come in and say, well, here's my really crappy idea, and you know, I'm never going to make this, and Tom made me do it, and that's why I'm up here presenting, and I'm not really happy about this. Don't do that. Make it like your game is like the best game ever, all right? It's much better, and it goes better, and everyone feels happier about it if you're happy. So stay happy when you present. But other than that, again, just to recap, tonight, contract is due at midnight. Your lab by now should be handed in, which is due at 5:30, so it should be handed in. If you haven't done it, you've got a few more minutes to get it done, right? And next week, you get your presentation due. Other than that, guys, thank you so much for sticking around today. I really appreciate you coming in, and we'll see you next week. I'll put this up on GitHub.